Okay, for math this week, we're going to focus on two concepts, and both of those concepts are found within the same lesson. 1.4, surface areas of right pyramids and right cones. So we're going to do, there will be a recording on right pyramids and there will be a recording on right cones, and that will be your math for the week. Those two concepts will certainly be enough for you to focus on. All right, so let's begin with the right pyramid. The right pyramid, looking at these three pictures, let's start here. This one is a right pyramid based on a square, and the reason why we call it a right pyramid is because in the middle of the pyramid going straight up we have a right angle. Starting from this corner going to the middle and then going straight up to the peak, there's a 90-degree angle formed right in the middle of the triangle. That's why we call them right pyramids. And this will happen whether you have a square, a triangle, a rectangle, or even a pentagon as your base. That's why we call them right pyramids. If you will have a triangular face each time, here, going around, depending on the size of your pyramid will depend on the size of your triangular faces. Okay? And you will need to basically find the area of each triangle. Now, if it's a square, then you can find the area of one of them and then just times 4, right? Because it's a square, 4 sides, so each triangle will be the same. So we have to recall the area of a triangle. Let's record that right here as a reminder. Area of a triangle. Base times height, BH, base times height, divide by 2. That's simply because a triangle is half of a rectangle. A rectangle would simply be length times width, of course, or a square would be length times width to get the area. A triangle, remember, is based on the idea that it's half of a rectangle, so base times height, which is the same as length times width, divide by 2. And you need the slant height. So you need, if you look here, you need this height of the triangle on the outside of the pyramid for each triangle. Unless they're all the same, then you figure out 1 times 4 if you're dealing with it. Like if you were figuring out this one, you'd be able to figure out 1 and then times 4, and you're finished. But anyways, area of a triangle, very important when we're working with pyramids. Base times height, divide by 2 is the important thing to keep in mind. Finding the area of a triangle. So, checking here, we have a triangle, a pyramid that's based on a triangle, so it would have 3 sides. We have one that's based on a square, so it would have 4 sides. We have one that's based on a pentagon, which is 5 sides. Could also have a rectangle, which would still be 4 sides, but the sides wouldn't all be the same length. 2 sides would be the same length, and then the other 2 sides would be different lengths if you're dealing with a rectangle. But here we have a triangle, a square, and a pentagon. And so you would simply proceed to figure out the area of each triangle, and then of course the area of the bottom, which is either, again, here it would be another triangle, here it would be a square, so simply length times width, and this triangle on the bottom would need to be calculated in the same way as all the other ones, and then you get your total surface area. So finally, on the bottom, the surface area of a right pyramid is the sum of the areas of the triangular faces and the base. do some brief notes here. The sum of the area of the triangular faces and the base. And primarily we are using then base times height. The bottom of your triangle, the base times the height, divide by 2. Or short form, BH, divide by 2. Those are the fundamental things that you need to know when doing the surface area of a right pyramid. And again, we're not going to worry about cones at all during this lesson. So, let's begin with this one. We have a square pyramid. Each side of our square is 8 centimeters, and we have each triangle with a height of 10. Let's begin with that one. Mitos Krodo. Okay, so we have a base of 8, and then each triangle has a height of 10, and each triangle will have the same base, which is 8, because we're dealing with a square. A square is the easiest one to do, so let's start with that one. So here we're dealing with square pyramid. Base 8, slant height, which is the outside height of each triangle. A pyramid, of course, goes up on a slant, so we call it a slant height, 10. So, let's do the triangles first. There are 4 of them, right? Triangle, base times height. 8 times 10, divide by 2. 8 times 10 is 80, divide by 2 is 40. How many triangles have we got? It's a square, so we have 4 of them. So we simply proceed with 40 times 4 is 160. Now all we have left is the square on the bottom, and that's of course an 8 by 8 square. Square is 8 times 8 equals 64. We get our total, which is 160 add 64. So 60 add 60 is 120, right? So that becomes 224 square centimeters. Centimeter squared, because the original measurements up here could have put that. They were in centimeters. 224 square centimeters is this example. Let's have a look at a triangular pyramid. That will go with this one right here. Nicely provided. A triangular pyramid where the base is 9 and the slant height of each triangle is 7.8. So we're dealing with the same base. We have each triangle is the same, has a base of 9 every single time. Okay? And we're going to be dealing with 3 sides. So let's do that. A triangular pyramid is often also called a tetrahedron. But we're going to say, triangular pyramid. I'm just going to go grab a calculator quickly. You can pause a little bit here. Triangular pyramid where each base is 9. Slant height is 7.8. Your bases could be different, but your slant height is always going to be the same, right? They're all going up to the same peak, starting at the same place and going up to the same peak. So whenever you're working with a pyramid, all of your heights are the same, right? Coming up to the same peak, right? But all of your bases could be different. In this case, they are the same. So proceed to calculate the triangles. Base times height divide by 2. Nine times 7.8 divide by 2. 9 times 7.8, 70.2 divided by 2. Should be able to do that in our heads. Half of 70 is 35, and then the 2 becomes a 0.1. So this becomes 35.1 is the area of one triangle. Now, how many triangles have we actually got? Well, we've got 3 plus the one on the bottom, right? The one on the bottom is also a triangle with the same measurements. Okay. They've all got the same base and the same height. That's the information that we have. So the bottom is also a triangle. Like, let me just quickly show you again. Right. You've got a triangle 1, 2, 3. And then you've also got the bottom, right? So you're dealing with 4 triangles. We now found the area of one of the triangles, so all that's left to do is 35.1 times 4. That's it. Simple. 140.4 centimeters squared. Yeah, let's do another triangle. There's one on the page right there. This is my loose leaf here. Do another triangular pyramid. The other one on 28 there. We'll do that one. So this has slant height 4.3, base of 5. So again, in this case, each triangle is the same, including the one on the bottom. So let's do the triangular pyramid. Each base is 5. Slant height, which will again always be the same, 4.3. Okay. So what do we do? Base times height divided by 2. 5 times 4.3 divide by 2. 21.5. take 21.5, divide by 2, 10.75. There's the area of one triangle, and again, this is the same as the previous question. How many triangles have we got? We've got 4. 10.75 times 4. 43 meters squared. That, by the way, is a big pyramid. A square meter is big, right? 43 square meters, that's a pretty fair sized pyramid. You could fit a few pharaohs into that one. Okay, with that, underline this part, and we're going to do a rectangle next. We'll do a couple of rectangle examples, and then I think that should be adequate for this. A right rectangular pyramid has dimensions 8 feet by 10 feet and a height of 16 feet. Calculate the surface area of the pyramid to the nearest square foot. So here's the diagram. 10 by 8 is the bottom square. So each two of the triangles are going to have a base of 10, and 2 of them are going to have a base of 8. We have a slight problem here. We don't know the slant height. They're giving us the straight height. Do kroot auf I mitten, right? We want to know the slant height on the outside. How can we get that? Well, remember that it forms a right angle. It forms a right triangle. So in this case, it forms a right triangle that's 16 feet by 4 feet. Like if the base is 8, then halfway in is 8, right? And if this base is 10, then halfway in is 10. So we're dealing with 2 different slant heights here in this particular case. This problem is a bit, I don't particularly like it. I'm going to change it. I feel like it's a bit too much to swallow for you right now. Okay. I got cut off there with my recording. So we'll start again with this pyramid on page 29 that I was talking about. So this is 8 by 10 with a height of 16. And what we're going to do is it's the straight height. So we're going to say, okay, I'm going to go with a slant height here. I'm going to assume that this is a problem where we already know the slant height, and I'm going to proceed based on that. All right, I hope that makes sense for the question on page 29. So let me grab a sheet here. So we're going to say, I'm going to just make up a slant height. In fact, I'm going to take the one that they have here, that they've figured out, and we'll do a problem where we've already got the slant height, and then we'll do a problem after that where we find what the slant height is. So we have a rectangular pyramid. We have an 8 by 10 square, and then we have 2 different slant heights, right? Because it's a rectangle, so 2 of the rectangles will be the same, and then the other side will be the same. So slant height number 1 of our first set of triangles is going to be, let me see. 16.5. And slant height number 2 of the second set of triangles. Let me quickly. 16.76, so 16.8. Now, before you get too excited, let's go back to the diagram and explain what I just did. We have a base of 8 by 10, a square. Then we have this slant height over here. This slant height over here is the longer one, okay? And it is 16.8 on this side. And then the front and the back would have a height of 16.5. Okay, so we've assumed that we know what the slant height is instead of figuring it out. So this is 16.8 slant height. This is 16.5 slant height. Okay. Let's do it. So slant height number 1, the first set of triangles. The base of those triangles is 8, right? Go first set, 8 times 16.5 divided by 2, base times height divided by 2. Let's record that. That comes to 132. Divide by 2 is 66. Times 2 again is going to bring me back to 132 for the first set of triangles, and that's in square feet. The second set is 10, right, by 16.8. $168 divide 2, 84, base times height divided by 2. There's 2 of those triangles. 84 divided by 2 is simply going to bring me back to 168. Now the square on the bottom is an 8 by 10. Add 168, add 80, 380 cubic feet. Okay, it's just that easy, folks, just that easy. Okay. Once you know your slant height, it's not that different from dealing with a triangular pyramid. It's just, or a square, it's just that your triangles aren't all the same. Now let's do an example, and I'm not going to do the one in the book here. I'm going to do one that I made. Let me grab a sheet. There's going to be sheets available for you. I'm going to put them on the back cabinet for when we get to this question. We'll put them over there now. This class will be available on Tuesday morning, which is when the next math period is. I'm not going to have anything uploaded for Monday. It'll be available on Tuesday. And I'm going to wrap up with this example right here. Now, the first thing you want to do is cross out this and this, because this was designed, this question was designed to do the volume of a pyramid, but we are simply going to use it to do the surface area of a pyramid. Okay? Simple as that. We don't have our slant height here. We have our straight height. So we need the slant height here and here. And of course the other side is going to be the same. Slant height here, slant height here. Now take a close look at what you need to do to find the slant height here. You want this distance. You already have this. So you want this. Those two together make a right angle, which will then allow you to find the slant. So what is this distance from the middle to the outside? Well, look at the base out here. It's 8. So then what's the distance from the middle to the outside? It's 4. So let's do our first slant height right here. 4 squared add 6 squared equals c squared. A squared plus b squared equals c squared, right? Good old Pythagoras will help us find this. We've used him before, haven't we? 4 squared is 16. 16 squared is 36. That comes to 52. I will need a calculator for the square root of 52. It's not a perfect square by any stretch. Square root 52 comes to 7.2. Now I want the slant height of the front here. It would be the same as the back. So from here, we already have the 6. The height is the same, but to get this slant height, we need this distance down here. So what's that going to be? Well, here we have 7. That means this will be half of 7, which is 3.5. 3.5 squared add 6 squared equals c squared. And we simply plug it in there. 12.25 add 36 equals c squared. $48.25 when I add them up, and now I need my square root. 6.94, so we'll go with 6.9. So now we have our two slant heights. Now essentially this problem just becomes the same as the one that we did a few minutes ago, right? It's gleich hadith, right? So here we have it. We've got our slant heights now. This one being $7.2. This one being 6.9. Essentially, that height in the middle doesn't matter anymore. It served its purpose. Okay, let's do this triangle first. Base times height divided by 2, right? So let's call it T1, triangle 1. 7 times 7.2 50.4 divide by 2. Of course, there's 2 of them times 2. 50.4. T2. 8 times 6.9. 55.2 divide by 2. Base times height divided by 2, right? 27.6, there's 2 of them, times 2. 55.2. And then the square or the rectangle at the bottom. R. 8 times 7. It's 56. 50.4 at 55.2 at 56. 161.6 inches squared. There's our surface area. I hope that helped to have an example based on a diagram on a piece of paper versus trying to model with the example they have in the textbook, which didn't really even have a picture. I hope this one was easier to follow. Not a lot of homework here. Page 34. Numbers 4 and 13. And let's just take a quick look at those in our trusty textbook. And then we'll wrap this up. Number 4 on page 34, couple of a square pyramid. So here you have a base of 6, a slant height of 11, right? 11 times 6 divide by 2 times 4. It's a square. They're all the same, right? The triangles. Once you have that, then your square is 6 times 6 added up. Here you have a triangular pyramid consisting of 4 equal triangles. Base times height, we have the slant height already. Base times height, divide by 2. How many are there? 4 times 4. Here we have on 13 now, a rectangular pyramid where they give us the slant height. Okay, so then we're going to do 2.8 times 9 divide by 2, then times 2 for the other side, right? 5.4 times 8.7 divide by 2, then times 2 gives us the other side. Okay, that's the surface area of all 4 triangles. The rectangle on the bottom, 5.4 times 2.8. Simple. And then add up your 3 numbers just like we did in the examples. This is the same, this B is the same as the last example we just did. You have to find your slant height first using a squared plus b squared equals c squared for both sets. Excuse me. So for this one here, and for this one here, find it for both sets. And once you have your slant height, then it becomes the same as A, just like we did. So here, what you're going to do, you want a slant height. Well, it's the straight height is 10. So what's half the distance here? Well, this is 5, so this is 2.5, right? 2.5 squared add 10 squared equals c squared. Okay. And once you've done that, you've got your slant height here. Good. Now you want the slant height here. Well, the height is still the same, 10. But what's the distance from here to here? Well, the total is 8, so it's 4. So 4 squared add 10 squared. Okay. All right, so just 4 and 13. 4 I'm hoping will be easy. If you have any difficulties with 13, just please ask. Okay, don't stew over it. Don't fret about it. Ask the question. Okay, how come a recording is that's so weird? I don't like this one bit. Es ist schon wieder spaßig.